Hey, today we're going to talk about heat and how we can determine the change in heat energy in a reaction. Okay, get out your reference tables. We're going to focus our attention on two places, table B and table T. We have the heat problems. So when we look at the heat, we have four different terms now, or four different variables that are a little new to us that we haven't seen before. Q means heat energy, it's enthalpy. It's measured in joules. C is specific heat. The specific heat capacity for water and other constants for water are found in table B. The specific heat capacity for water is 4.18 joules per gram degree Kelvin. And what that means is it takes 4.18 joules to raise 1 gram of water 1 degree Kelvin, or 1 degree Celsius. So the specific heat just means how much you have to heat, or how much heat you have to add in order to change 1 gram of that substance 1 degree. And specific heat is different for different objects. As you recall, metals have a high heat conductivity, so metals will absorb heat and transmit heat energy fairly rapidly. So metals tend to have a low specific heat. A very high specific heat is found in water. And of all the common substances, water has the highest specific heat capacity. In other words, it takes a lot of energy and a lot of heat energy to raise the temperature of water 1 degree. The more water you have, the more heat energy is required to change that temperature. And remember, temperature is a measure of average kinetic energy. When you see heat, you think of this. When you see temperature, it's average kinetic energy. All right, now we have HF and HV. HF is heat of fusion. It is the amount of heat it takes to melt water. So this is the amount per gram. It is 334 joules for every gram of water. And the heat of vaporization, remember when something becomes a vapor, it's boiling. So the vaporization is how much heat energy it takes to boil a gram of water. And this is 2,260. 334, 2260. Okay? Now we're going to look at the back page. We're going to look at table T. And we have a couple of problems. Okay, how much energy is required to raise the temperature of 100 grams of water from 50 degrees to 60 degrees? When you see this, you're looking for one of three equations. We have Q equals MC delta T, Q equals MH sub F, and Q equals MH sub V. Now, we're going to look, since we are just changing the temperature of something, we are raising the temperature, we are not actually changing the phase. We're going to look for the one that has a change of temperature. In other words, we're looking for the equation that has delta T. Now, if we look, it says how much energy. Right here, I know the energy is Q, delta T. Now, I also have this value, which is mass. Okay? So I have most of these values. I'm going to be using the equation Q equals MC delta T. Q is my unknown because it says how much energy. So Q equals M is mass, 100, times C, which is the specific heat capacity for water, which means we got to look on table B, which is 4.18, times the change in temperature, delta T. Now, I'm not going to write 50, I'm not going to write 60. I'm going to do the difference between 50 and 60, which is 10. So Q equals 41,800 joules. That's how much energy it takes to raise the temperature of 100 grams of water for only 10 degrees Celsius. Okay, here's another type of question. How much energy is released when 50 grams of liquid water freezes at 0 degrees Celsius? So I'm going to look at table T. And it's not going to be anything with the change of temperature because I don't have any temperature changing. I have potential energy changing, which means I'm going through a phase change right now because liquid water is freezing. Now, if I look at this, it's either the heat of fusion or the heat of vaporization. So what I have to do is think about what's happening when liquid water freezes. It's not vaporizing. Vaporizing, remember, is boiling. So it's going to be the other one. So fusion could mean either going from solid to liquid, which means energy is absorbed, or it can go from liquid to solid, which means energy is released. In this situation, energy is released. We're going to use HF. So it's Q equals Q equals MHF. So what we have here, it says how much energy. That means that's our unknown. Q equals M, which is mass, it's 50, times H sub F. I'm looking at table B. For that is 334. So 50 times 334, when I multiply that, it is equal to 16,700 joules is released. Okay? I hope that this is self-explanatory to you. Basically, to summarize, all you really need to pay attention to is what's happening. Are you changing the temperature or are you changing the phase? If you're changing the temperature, you use the one with the C and the delta T. If you're changing the phase, you use these, and you may have to look at table B if it is for water. Good luck, practice problems.